Welcome back to another episode of Facilitate TV. I'm joined by Brent from Vitrafy. Thank you for coming on the show.
Thank you, Ben. Great to be here. Thanks for having me.
Excellent. Can you take me quickly through what Vitrafy does?
Vitrafy is a cryopreservation technology company that comprises both hardware and software. So cryopreservation freezing devices, thawing devices, and a software platform that sits on top that in combination materially improves the outcome of cryopreserved materials.
Excellent. Yeah, usually when people think of cryopreservation, right, it's like, all right, well, I've got my can of liquid nitrogen and away we go and whatnot. So this is really interesting. I'd love to learn a little bit more about this ecosystem of both the software and the hardware. So can you take me through an example of one of the ways that your software solution that kind of sits on top of these different devices really ensures better outcomes?
Absolutely. It's a great question. And I would say historically, rightly or wrongly, it sort of doesn't matter, but cryopreservation's been treated as just the step of freezing, and it just happens.
Yeah.
But if you want to get the outcome, so the point of freezing is to use it later down the track for many reasons, but if you want the quality at the end, then it needs to be across the whole workflow to get that outcome. It's not just the step, it's actually the process end to end. Now, when we think about our hardware, there are different steps in the process, but they connect to the overall end-to-end, which is where the software becomes important. So inputs across the supply chain feed into the software, which then help design what the heat curve needs to be for that specific material, because it's not a one-size-fits-all approach. Different materials require different conditions.
Gotcha.
Built into the software is a lot of the intelligence, which we have our own database and algorithms that you can then deploy to the hardware to reconfigure for that specific material itself.
Right. Okay. So let's say, for example, right, I'm a cell therapy developer. I'm cryopreserving my allogeneic material for later. What would be some mistakes I'm probably making in my cryopreservation process that a combination of software and hardware can make sure never happens again?
Yeah, it's a great question again. I will say, if you're this is I guess the evolving industry of advanced therapies, is it's quite tailored. And a T cell doesn't freeze the same as an NK cell.
Right.
And an NK cell doesn't freeze the same as a leukopak. And the volume and the replicates and the geometry are all different. And you need to be able to customize for those different conditions. One of the challenges today is it's a bit of a one-size-fits-all approach, and that's where you start to see variable outcomes occurring as a result. Vitrafy's technology, hardware and software combination, can identify the best conditions for T cells, NK cells, leukopaks, and different formulations. It can then control the hardware to reconfigure how it operates, suitable for that material, that volume, and that specification as well. So developers now have an opportunity to have customizable cryopreservation conditions to retain the most amount of sample outcomes as possible.
Gotcha. So if we'll shift gears here a little bit and imagine that I'm a gene therapy developer, what are some common mistakes you see people making early on in their cryopreservation strategy?
Again, I would say overall, no matter what the application is, in many of our experiences, it's been a one-size-fits-all approach. Put it into a freezer and it'll just work at the end. It actually, that's where you've got then cryoprotectants coming into it to try and protect it from a cellular level and biological level, but there's no real engineering solution to go with it. So we've come up with engineering solutions that can be tailored for the specific material, whether that's for cell therapy developers or gene therapy developers. We've got the capability to optimize for both.
Gotcha. Interesting. So on the side of bringing your cells out of cryopreservation and thawing them effectively, what are some of the best practices you've seen around doing that? And maybe even you can throw in a mistake that people use that just immediately destroys the cell population or something.
Well, I will say, I don't know how widely known it is. DMSO is not the greatest, but it does have a purpose.
Yeah.
And I think we have to be clear about that. But at +2, with some of the work that we've done, +2 Celsius, you start to cause toxicity to the cells.
Yeah.
If you're dumping a bag of material that's going to save someone's life that's worth a couple of $1 million into a bucket of water at 37 degrees Celsius until it visually looks like it's changed state, it's going to get above +2.
Yeah.
So you start to cause damage. And I would say that it's almost standard in many cases to do that. that seems so outdated, and it's quite bizarre to even think. There's now thawing technologies, Vitrafys, as well as many others, that have a new approach so that you can mitigate some of these in a controlled way, but then factoring in some of those other things like the toxicity of the DMSO is really quite important, so you avoid toxicity and damage to the materials itself at the thawing side of the equation. Even better if you can remove it at the upstream.
Very good. And then I guess with regards to how you see cryopreservation continuing to evolve into the future, is there anything that you're seeing by the year 2030, for example?
I'd say with the personalization and the customization, there's a growing need. I think that there's obviously philosophical and hypothetical situations that would remove the need for it in many cases, which is great.
Yeah.
I think that whatever's best for market and patients is number one. I have a very strong belief, though, that the need for cryopreservation will only increase because of the personalization and decentralization in many cases too. We want to be able to deploy our technology to provide cryopreservation solutions to every point of collection in the country,
Right.
so that it's available to get the best quality outcome for patients when they need it.
Excellent. Well, thank you so much for coming on. This
Appreciate
has been great. I think I've got a much better understanding of cryopreservation now.
I'm glad. Plenty more to come too.
Excellent.
Good stuff.
Thank you.